So some parts arrived in the mail today, so I got busy building or soldering everything together for my sensors. I'm going to get this all put out there in the tank tomorrow, I believe, assuming everything with the ADC works out as well as I think it looks like it is. So anyway, I was waiting on this board. It's a proto hat. I guess you can see toe hat upside down there. It's just a simple, it's like a breadboard kind of, so like there's these 5 pins are all connected and those 5 pins are connected and stuff, so you can easily connect one wire to the other just by soldering them into those holes and whatnot. The chip measured correctly to go in. It swallowed one column of pins, but that doesn't really matter since this is the ADC. You're really only going to plug like one data line into each one of those channels. This is a MCP 3008 chip, and that arrived today also. The Raspberry Pi doesn't have analog to digital conversion built in on the board, so I had to procure this to do it for me. Because the pH, the output from that pH receiver board is an analog signal, so which corresponds to the pH that's measured. So I had to add one of those, and it's pretty simple. Wired the Raspberry Pi's hardware SPI interface pins to the clock and data lines for pulling the serial bits out of that chip for each of the 8 channels. In this case, we only wired up one of the channels, so that chip is way overkill. I could have bought a 4-channel chip, which would have been a few pins less, or I don't know if they make smaller ones. I'm sure they do, but anyway, this is what I got. Anyway, so yeah, that's that whole circuit. This blue pin goes into channel 1. And this is the reference 5-volt reference voltage, so the chip will assume that if it equals that, then that's a maximum 11 bits all ones reading. And there's a analog ground, the reference ground, so if it equals that value, then it's 0, and then anything in between will be appropriately high. But anyway, so yeah, so that's the hookup for the pH meter. This is we call it a 1-wire bus, where the system reads the values from the sensors. All of the wires are connected on a single bus, on a single data pin, so we only use GPIO pin 4 to read all 3 of those sensors. There's just a simple 5k ohm pull-up resistor connected to those lines, and then of course the red and the black from each of those 3 cables is tied to the 5 volts and ground as appropriate. So that's for the 3 temperature sensors. And then down here I have a wire, I have it wired up for the ultrasonic rangefinder board. I repurposed an old USB cable that was no longer functional. I think one of the connectors was busted, so I just chopped off the ends, and it had a nice shielded 4 wires that were actually the right colors for my purposes. They're red and a black, and then 2 data lines, green and white. In this case, the white is the echo line, the response line coming back from the speaker, and the green is the line for making, or the white comes back from the microphone, the green goes to the speaker for output. And so I wire the green directly to pin 23, and then for the input, since I don't think it would matter too much if I put 5 volts into the GPIO pin for plus and 0 for minus, or for 0 for 0 volts for false, for 0. But the wiring schematics online said to do a kind of a 1 to 2 resistor mesh basically, so you get like 2/3 of the value. So 5 volts becomes 3.3 volts roughly, going into, so there's the white wire going through a resistor with another resistor to ground, so that center point will be roughly 3.3 volts if it's on and 0 if it's off, and then goes into pin 24. So that steps down the 5 volts to 3.5 volts basically, for if it's a 1. So anyway, this is all soldered up, and I've tested everything, and it's working. So do a quick rundown of how things are working. I'm connected to the Raspi through this little putty terminal. The Raspberry Pi, if you're not familiar, has a onboard wireless connector card, or boards basically, so you can connect to 2 different wireless networks at the same time if you want. But anyway, I'm using one of them only, and it's then I turn on SSH, so then I can connect to the Raspberry Pi remotely. So this is my PC talking to the Raspberry Pi, and so I've already changed to the one wire system device basically directory, and as you can see, we've got 3 devices now, all with the 28 heading, which I think indicates that it's this specific type of thermometer sensor, and then a unique serial number for each of the 3 devices. The first 2 are 031-6B is how they start, and then it's 4E blah blah, and then 5B blah blah. Anyway, that's 3 different thermometer sensors, and they all seem to work just fine. By way of a demo, we'll just cat. Let's just do the first one. Well, we'll do the third one because we've never hooked that one up before and shown it. 05 tab, it auto completes, and then the file in there that we want to cat is W1 slave. So we look at that file, and it tells us that the temperature is 23.75 degrees Celsius, which is a little over 70 degrees Fahrenheit. That seems right to me. So then, if we want to check the ultrasonic sensor, see if it's working, CD2. I made a folder called Aquaponics, and then it's a Python script, Python ultrasonic 1.py. Oops, ultrasonic 1.py. And it said 155 centimeters. But then if I move my hand over quick, it says 21.4, 9.2. So, because I got even closer. So that thing's working fine. I don't know if those values are, how close to accurate those really are. I do know that it seems to be pretty like repetitive. Like if I keep it from a same distance from a device or something that I stick out, it seems to return the same value over and over. So at the very least, I can calibrate it to give me a rough estimate of where we are, where the water level is inside the tank. And then to check the pH meter, that is in the Adafruit Python MCP. There's a test. There's a sample code that came with it that'll just spit out the values. Simpletest.py. So sudo simpletest.py. Oops, that's not executable. So Python simpletest.py. And it just spits out. So there's 0 to 7 is the 3, or are the 8 channels, and channel 0 is the one we care about, and it's at 435, 433, 434. So I need to translate that into a pH, but I have some code to do that. I just haven't hooked it up yet. But this is evidence that A to D converter is working. Pin 2 seems to be floating a little higher than the others. I'm not sure why. I suspect, though, that if I connected that to, some value, it would read it more directly. But anyway, all of the hardware seems to work. So now it's just a matter of maybe putting this thing in a box to protect it from the elements. Putting some standoffs to hold, like this thing's all just connected to the board with this terminal, and so it's a little wobbly. There's nothing on this side to hold it down. So it came with some standoff, little brass standoff guys and some screws. I'll see if I can't get that in and maybe mount this to the inside of a little plastic box or something for now. And then maybe use some structural masking tape to attach these cables to the edge, the surface of the plastic, so that they don't get ripped out accidentally. And then just plug everything in. So that's the plan. I've got a simple yes, I want to close. Once everything is reading data, then I want to store it on a web service running on this PC in the house. So we'll just do a quick. I've built a simple web service. It's not done yet, but it's getting close. We'll look at the. Right now, it's just a simple REST service. Count, I think, was generated by the Visual Studio. Like that, if you want to make people log in and authorize access to things, I think that's what it counts for. But Aquaponics System is to say, like, I've got, maybe you have 3 setups. One is just a little simple one inside the house for growing herbs and stuff with some decorative fish, and another is out in the yard in a greenhouse with tilapia, and it's a bigger system, and you keep their data separate because they're unique water cultures and whatnot. I don't know, but so anyway, you specify, you create an aquaponics system, and then you specify containers, which are like aquariums or fish tanks and garden beds, and anything that holds water and might have a sensor in it will be a container. And then sensors are the probes, the temperature probes, and sensor data is basically I'll have the Raspberry Pi. I'll have some code running on it that is just taking readings all the time and periodically writes them to the aquaponics logger that I have here. And so, like, I could do a demo of it working, but I was playing earlier, and I think I broke the aquaponics system functions, and the other things aren't quite finished yet either, because I made some changes just a bit ago. So right before the breadboard got here, and so once it got here, I dropped working on the code and started working on that because it was more fun. But yeah, so the Raspberry Pi will be recording data onto this web service, and then I can do other things, like I can make a simple chart page on this web app, so that I can monitor, like, the temperature fluctuations inside the tank and the water level fluctuations and like how fast the water is evaporating and that kind of stuff, to get some metrics. And then, of course, also I can maybe build a phone app. Well, this thing I could set up some triggers, like if the water level gets below X, then send an email or whatever. And so that would be pretty easy to add to this. But I might also build a really simple phone app that will check in with this and raise like an actual alarm on my phone if something bad happens, or let me check things from my phone anywhere, anytime. I might also add like a fish cam to this site, but all of those things are up in the air and future work. What I really care about for now is just logging this data, getting it started logging, and then I'll add functions, features to this site as I go. But anyway, I'm really pretty pumped that once I got this stuff wired up and soldered together, that it all started working. I didn't really have doubts that it would, but it's always affirming to, test a project and not have bugs. It makes you feel all, squishy and happy inside. So that's all for now. Once I get this stuff plugged into the system tomorrow, and maybe once I get these services polished so that it can actually start recording data, I'll do another update tomorrow evening. And then I'm going to Kansas for the eclipse after that, so it'll be a little while before I get any more updates, but updates are definitely forthcoming. Go Aquaponics.